Time for the third video. So in the first video, we told you about the core staff. In the second video, told you what Code and Place is about. And in this video, we're going to get into some content. And you're going to meet Karel. Now, of course, you've gotten to this place in the course because you've already solved some Karel problems. So you've learned a lot of this from the Rater. But now I'm going to go over some of the things you learned so we can go deeper and make sure that you understood those critical concepts that you may have used in the application to Code and Place. So everybody, we're going to meet Karel. Class, meet Karel. Karel, meet the class. Karel is a lovable robot that we've been using from, I think, the 1970s to teach programming at Stanford. And Karel is a robot, does not speak English, instead speaks a thing called Python. Karel was invented by a PhD student, way back in the day, as a gentle introduction to programming, with the idea that if you want to learn a language like Python, let's give you a tool set where you can focus on all the most important parts and not have to worry about some of the memorization that would typically come when you're learning programming. Karel was invented. So Karel speaks this thing called Python, which we're going to be using as our programming language throughout the course. There's a lot of programming languages. You might have heard of other ones like C++ or Java. And I wanted to explain quickly why we chose Python. I mean, one of the simple answers is, by some definitions, it is the most popular programming language in the world. So there's many ways that you can program, and we're going to teach you one of the most popular ones. But that's only half the reason. The other half the reason is we're very convinced that it is the best one for teaching. It is the most useful programming language to teach you the fundamentals and the best practices. So we're going to be teaching you in Python. That's the language that Karel speaks. As a small aside, Python was actually invented by a person. There's a person who's like, I want to make a programming language. I'm going to call it Python. That person was Guido van Rossum. And just in case you're curious, it's not named after the snake. Instead, it's named after this TV show called Monty Python's Flying Circus. A little fun fact you can tell your friends. So Karel is our lovable robot, and Karel lives in a world. We think of the world as kind of having a north, west, south, and east, and having compass directions. And in this world, there's not that much. There's walls, and Karel can't walk through those walls. And there's beepers. Beepers might not seem exciting too, but beep servers are basically the most exciting thing in all of Karel's world. Karel can pick those beepers up, and Karel can put those beepers down, in addition to move and turn left. Karel only knows those 4 commands. But using all these 4 commands, you can solve incredibly complicated programs using Karel. The first command that Karel knows is move. And you know what move does. If Karel's standing on a square and you call the move command, Karel just takes 1 step forward. So there you go. Karel just moved. Next command for you to learn is turn left. And that does exactly what you expect. When we take, hey, Karel, can you turn left? And you execute the command turn left. Karel does, wait, what? That's the weirdest turn left ever. I thought he would just turn left. When I turn left, I don't flip in the air. Yeah. When Karel turns left, Karel actually rotates a quarter turn anti-clockwise. And I'd say this is actually one of the most complicated things about Karel. A good way to think about this is to imagine that you're a bird looking down at the world, and then Karel is a person on a map. And so if Karel's facing east, and you're facing this direction, then you turn left, imagine a street corner. Then after you turn left, then Karel's facing now north direction. So that's a good way of thinking about how Karel turns. Another good way to get used to it is just to have Karel turn a lot and then get accustomed to it. Certainly one of the strangest things about Karel. Now, a small aside, did try to change it. I tried to make it so that Karel looked like something that you're looking at from top down. But people have grown so in love with this little Macintosh-looking robot that is impossible to change. I mean, people make huge cardboard cutouts of Karel at Stanford. We just care about the robot too much to let something silly like the robot turns left strangely to get in the way. So the most complicated thing about Karel, now you know. So if you keep turning left, now you're facing south. And then if you moved in this direction, it's like you're moving in the direction that you're facing, assuming you're looking from the bird's eye view down. So now we've talked that Karel can move, Karel can turn left, and the next 2 things are pick beeper and put beeper. So pick beeper, if Karel's on a square, if there's a beeper and you call pick beeper, that beeper just gets picked up and put into Karel's bag. You can only call pick beeper if there's a beeper there, otherwise it will cache Karel's program. Okay, and put beeper. places a beeper. You can place as many beepers as you want on a square. Here's our first challenge. Let's see if we can write a little program together that can get Karel to move from this position to this position. So it's like Karel picked up that little beeper, stepped up on this ledge, and then placed it down. How are we going to solve this? Well, I want you to think about it for a second. What series of commands would you use to get Karel to pick up this beeper and end up on the step? Now, to help you out with this challenge, I'm actually going to call on past Chris. I'm going to give you a blast from past. I'm going to give you a little snippet of a video that we made in the very first Code in Place where I went outside and I worked this through step by step. So, hey, past Chris, take it away.
To solve this problem, I actually went outside and put down a Karel mat, and I set it up so that we can think about this problem one step at a time. So I wanted to search for a volunteer. Someone can help me solve this problem. And I figured, maybe we can all do it together. So I went to a little park near my house. I got this little water ball, which I called a beeper, and I created a mat that looks just like the world we're trying to solve. Karel is played by me. I had to volunteer for myself because everyone was sheltering in place. There's a beeper, and we like to pick up that beeper and put it on the top of the ledge. Let's think about this step by step. Well, first thing we do is move. After you move, you're on top of the beeper. So what can you do next? Yeah, you can pick up that beeper. So you can move and pick beeper. Then what? You can move. Then if you want to get to the top of the left, use your turn left. And then you can move. Now we should pause. At this point, what we'd really like to do is we'd like to turn right. But if you look carefully at your set of commands, Karel doesn't know how to turn right. Karel only knows how to turn left. So if you want to get Karel to turn right, how could you do that? You can think about this, but I'm sure you guys would come up with the answer, which is if Karel can't turn right, Karel could recreate the ability to turn right by turning left 3 times. So we can have Karel turn left. Come on, Karel, turn left. And then turn left. And then turn left. And we've now created turn right. Now we can move, put beeper, and move. Fantastic.
Thanks, past Chris. Now, if only we could do all of our programming outside walking on a mat, that would be fantastic. Obviously, we don't. We do most of our programming on computers. And because learning by doing is such a core course value, let's talk about how you could actually program yourself. When we program, we use an application that has a fancy name, and the fancy name is IDE. It stands for Integrated Development Environment, but what it means is the application where you do your coding. There are many. We have our very own for Code in Place. We think it's like the world's coolest, especially for people who are learning to program. There's other ones that you can download for your computer, things like PyCharm. We very much recommend that either sometime during the class or after the class, you download one of those IDEs because it's just great to have it on your own computer. For all of Code in Place, though, you can just use the Code in Place IDE, and you're going to be learning the exact same programming that you learn in any IDE, just with a couple extra tools. So let's jump into our IDE and let's solve this problem. So here we are in our editor. And this is a place where we can do all of our programming. It's an IDE. In an IDE, the most important place is where do you write your code. So this is the editor, the place where we write our code. And then you can see your code writing over here in the world. This just describes the problem we're trying to solve. Now, right now, it doesn't have a solution. It just has Karel move. So we're going to have to edit this so that we can get Karel to do what we want. So instead of just moving, want to move, then pick up that beeper, move again, and then we want to turn left and move again. I love to test as I go. So let's test this. Let's make Karel go a little faster. Not that fast. And there goes Karel and gets to this point. This is looking really good. Now we're at that interesting place where we want to turn right. Now, one of the things I'd like to teach you is that when I code, I often leave little messages to humans, and I write these using comments. One of the ways of doing comment is to write this hashtag character, and then I can write a message, not for the computer to read, it will ignore this line, but just so that other people who are reading this program know what I mean. So I'm going to say, at this point, or I'm going to say, make Karel turn right. I'm going to write this comment because, turning left and turning left and turning left, it's not immediately obvious to a reader that what I'm trying to do here is turn right. But with this comment, it's a little bit easier. So I turn left, turn left, turn left. So at this point, I've turned right, and then I can just move, put my peeper down, and then move again. Let's try this out. Okay, Carol, you do your thing. Wow, fantastic. Now, if you haven't already, I strongly encourage you to get used to going back in time and thinking about how your program works step by step. So using this replay stepper, you can see, okay, I'm at this point in time. If I take one step forward, I'm going to call the move command. After I call the move command, look at what Carol does. And if you find anything confusing, you can just take it step by step so you can understand things at your own pace. Understanding the steps that a computer uses to solve a problem is one of the critical skills in programming. So please do use this. Right. Now, I made a big deal about one of our course values being the art of writing beautiful programs. And while this is a nice program, there is one way we can make it way nicer. The way we can make it way nicer is instead of calling turn left, we could call turn right. And at this point, you're like, wait, Chris, you told me there is no turn right. What are you saying? And I'm like, okay, there isn't a turn right yet because Carol doesn't know what a turn right is. But I'm about to teach you this critical concept, which is you can define new commands. So Carol doesn't know turn right. And in fact, if I try and run this program, I get an error that says there's no function called turn right. That error that there's no function called turn right is actually speaking to our solution. You can teach Carol new things. You can teach Carol a command that Carol didn't know before by doing what we call defining a new function. You can say, Carol, I'm going to teach you how to turn right. And the way I do that is outside of main. So after main is completed and indented in the same level as this def, I can write another def. The indentation really does matter. And I can give it a name. And if I write def and the main, what I am saying is I am teaching Carol the new concept, the new command of turn right. I write def, I give a name to my new command, I write open and close parentheses, and then I write a colon. And then I write the sequence of commands that I want Carol to do every time Carol's asked to turn right. So at this point, now we can say, okay, you know what, Carol? Turn right is actually just turning left 3 times. So we can turn left, turn left, turn left. And now we have a program that is functionally exactly the same, but we've done something so important. First, we've made this much easier to read. And second, we've introduced this new idea to Carol. And introducing new ideas, defining new functions, adding new vocabulary is the quintessential component that allows people to go from simple ideas like ones and zeros, making them more and more complicated till you build up to the point where you have a whole experience on a computer. This ability of programmers to introduce no vocabulary elements, it's not a small deal. It's a really, really big deal. And we get to practice it in the first lesson here in Karel. It's such a big deal that Karel was designed so that you can get introduced to it early. So the big concept, you can define new functions. To say that more concretely, if you want, you can teach new vocabulary to Karel or any Python program for that matter by using a def. And you write def, you give it a name, parentheses, colon, and then you write the function statements that you want to be executed anytime somebody wants to do the command with your name. Don't write actually name there. Give it something like turn right. Okay, so let's see how those fit into the whole program. Here's the anatomy of a program. A program has a main function. That's where you do def main. It then has all the helper functions. That's what we call those things where you introduce turn right, maybe turn around, maybe move to wall, whatever functions you want to introduce to Karel, we call those helpers, and they often we write them underneath main. And then there's some code to start the program. So your main function can be a sequence of commands, your helper functions, and you can have as many as you want, go one after another outside of the main, and there you can introduce new vocabulary. And then you'll often see this very confusing line at the bottom of a program. It says like, if name equals main, run Karel program, or maybe it'll say if name equals main, it'll call main. These lines are just saying, if somebody executes this program, start with main. And then also another important line that you'll see on each of your programs, you won't have to write for a while. They'll just be there in your starter code. You'll see something called an import. And an import says, when I'm writing this piece of code, I want to use another library. And so in this case, we want to use the Karel library so that when we're writing our code, the IDE knows all about this Karel we're speaking of. So there's a line like this. That's the anatomy of your program. A little bit of terminology so that you can speak like a coder. This piece of a program's source code is called a function. Code is actually short for this term source code, and source code is just the text that programmers write. This thing is called a function, and every function has a name, and this one's called main. This is also a function. This one has the name called turn right. A function has a body, and that body says what are the commands of the function. And critically, you see this green thing? All those functions should be tabbed in once. And that makes a code block, and the code block is how Python knows what's supposed to be inside of main. So a code block starts with a colon and includes everything that's tabbed in once. There you go. There's a few code blocks in this program. All these things that start with a colon and then are followed by a tab, those are code blocks. So there's a code block for turn right. It's really important that the definition of turn right does not exist inside the code block of main. Notice how we do the main, we finish main, and then after we finish writing main, that's where we introduce turn right. Pro tip. Okay. So that's the end of the first lesson, but really this is just a start. We talked about a lot of things that you probably already know. And in the next lesson, we're going to start growing on what you had to do for your application. Hey, what a joy to get to be your teacher. Welcome to Code in Place. I hope you guys have such a fantastic time and see you in the next lesson.